All right, everybody, welcome back to C++ for Java programmers. The last 2 weeks have indeed been quite rough for me. Thank you all for the messages and your patience. I can see my test results from Tuesday online, but I'm still waiting to hear back from my doctor to interpret them. It looks like low potassium is the only thing that came up again. So I don't know, I'm guessing genetics, but anyway, I'll hear back from her pretty soon. All right, so the plan for today, go ahead, download the template and the code. It's on online for today's lecture. You can follow along as you go through and actually try out all the demonstrations. Today we're going to be talking about the standard template library, starting with containers. These are just going to be built-in data structures. We're going to focus specifically in this lecture on the vector. That's a library to help us work with arrays, and we'll go through all the features of that. And then next lecture, we'll talk about all the rest of them, all in one lecture. Following that introduction, we're going to be looking at iterators. A lot of the standard template library is built around this idea that I'm going to have pointers to elements in a data structure. The algorithms library is about 50 or 60 different functions designed to work on ranges of data, like a piece of a vector or the whole vector. And we'll be giving those algorithms, like for example sorting, the beginning and ending part of the vector, and it will just use those pointers to iterate through the code or the data while it's sorting them. All right, to get started, I just grabbed some definitions off the internet. First one's from Wikipedia for data structure. Now, as we write code, we're going to need to make decisions about how to best organize our data, and we'll have specific goals for working with that data. We're going to want something that meets those goals, and we have lots of choices. So data structures are really going to give us storage of the data and the functions and operations that we can apply to that data to change it or modify it or sort it or whatever we wish to do. Built into C++ is the standard template library where we have containers, or their definite version of data structures. They're just going to be holders that store a collection of objects, or those objects could be primitives or objects like strings, or classes that we write ourselves. These are all implemented, at least all the ones I'm going to talk about, are implemented as templates. And a template in C++ is like a generic in Java. It just means that I can give it pretty much any type. I just need to tell it that this is an array of integers or an array of strings. So I need to give it a type. And that's what this templated idea is. All right, I've got lots of built-in choices to mimic like really common programming structures. So for a dynamic array, that's going to be the C++ vector. Queue is actually named queue. Stack is named stack. We want a heap. That one's known as a priority queue. The list is the classic linked list. Any of the trees, tree data structures are going to be sets, or if it's an associative array, then a map. And right along with all of these data structures and the containers, we're going to see that we have a collection of functions that are designed to go along with these templated data structures. The algorithms library is a collection of like 50 or 60 functions. This is where sort is. There's just a lot of them. Sort's the only one I'm going to work with today, but I'll bring out some of the others as we go through the remainder of the course and highlight how to use them, particularly in the very last lecture when we talk about function objects, but I'm getting ahead of myself. So it's just a collection of functions that are going to operate on range of elements. So if I have a vector, I've got a whole bunch of elements all in a sequence there, and these functions are designed to work on that kind of data. Anything that can be accessed with these iterators or pointers. All right, just to show you a little bit about how these things break down, I've got them sorted here. This is actually just a screenshot from the c++.com. Dividing them up into the sequence containers. These are going to be things that store all of the data in like adjacent memory locations. So it's going to give us really fast access if we have like an index. We've also got the associative containers down here, set, multiset, map, and multimap. These are going to be containers that are accessed by some sort of key. And then we've got container adapters are more specific. They're sort of like limited versions of these things, or they might add one extra feature. Like for example, the queue is actually based on the double-ended queue, also known as deck, and just limits what they do with the deck right here. So these adapters provide very specific focused functionality based on these things. And then for the associative containers, we've also got unordered versions of all of those also. So that's just a matter of how they sort the data internally and can affect performance. We'll talk about that in the next lecture. Also, so I've already just gone through and talked about whether containers are sequence or associative. Here's the sequence ones. We're talking about vector today. It's the second one down right there. So sequence versus associative. There's a great reading available linked on the webpage. You can go check that out. But so here's how I'm going to be classifying all of these containers and talking about the performance trade-offs. So whether it's sequence or associative, these are going to be accessed by an index or a key. Those are their choices. Now, some of them are going to be dynamically allocated, and some of them will have very fixed size. In fact, that's the primary difference between the array and the vector. The array is of fixed size, and the vector is dynamic. They're pretty much all going to be templated. What this means is I'll need to tell C++ when I'm creating a vector that this is going to be a vector of integers. So, and this is, and then finally, whether they are, whether the values are ordered or unique. So, and from now on, for the rest of this lecture, I'm just going to focus on vector. This is a built-in library that's designed to help us work with arrays. So during the last lecture, during the last homework, we struggled using all the different arrays and accessing them with pointers. This is designed to make all of that stuff a lot easier. It's a lot like Java's array list. So if you're familiar with that, this should look familiar. And you should expect there to be a lot of certain things available to us. It might be a matter of looking up, how do I do this thing from Java in C++? And I'll be going through a lot of examples for the remainder of the lecture. So the vector is a sequence container, so we're going to be accessing it by an index. And the bracket version of indexing, just like we saw with the primitive arrays, works just fine here. They've done their best to mimic that. It is dynamically allocated, so we can grow or shrink it without having to do any extra work. It's all going to be taken care of internally for us. So no more creating a brand new bigger array and copying everything over. The data is also going to be stored in contiguous memory locations. So I'm just going to get a block of memory, and every element is going to be stored, the next one is in the next couple memory pieces down. So access is fast. It's also not ordered. It's just the order that we decide to put them in. It's up to us, so it's not going to be sorted or anything. And we're not requiring the elements to be unique. We can have multiple copies of the same thing. So if I create, I guess what I mean here, if I create an array of numbers, I can put in 111, 22, so I've got multiple versions. They're not unique. And then I could also say they don't need to be ordered. I could put in 9, 6, 7, and it's not going to sort them for me. It's going to be in the order that I request. So next up, I'm going to pull up the CSL machine and just go through a bunch of examples of using vector just to get us started, show everybody how it works. All right, so here's what I'm starting with. I've just got my basic empty template. I've included IOStream and IOManip so I can print things out and look good. And using namespace standard, and then I've got an empty main right now. The template online, I'm going to be developing my lecture code, and then I'll go remove pieces of that. So the template will have a lot more of like the subheadings for you guys. It'll just be a matter of going through and filling them in. And I'll probably leave this, but the very first thing I'm going to need to do is include vector. It is a library that we'll need to bring in every time we want to use it. All right, and then let's see here. Let's get started by just how to create a vector. Let me just go ahead and type this. I'm going to create a vector called colors, and it's going to be a vector of strings. And then I'm just going to give it some basic colors. So go ahead and put 3 in. Let's see here. Put in red, green. I study computer graphics. Those are good colors. All right, so this is all we need to do. So I need the keyword vector, and that's just like if I were creating an integer. If I had int x here, this is the type, int x. The type of this variable is vector string, okay? And all of these are templated, so I need to use the angle brackets to say what kind of something it is. Some of the things will actually have more than one piece inside the template, like a map maps a key to a value. We need to give the types of both the keys and the values there. So, but in this case, I'm just creating a vector of strings, and so that's all I need to do. All right, let me go ahead, and I don't need that. But let's go ahead and print these out and just verify that things are working. So there we go. Let's go with cout, and then hey, let me type this real quick and I'll be right back. All right, so finish typing that. All it's going to do is print out the first color is, and then to access any of the pieces of data, I can use the brackets to give it an index number and just go ahead and look up. So this one should say the first color is red, and again, the vector starts at 0. So C++ is a zero-based indexing system. Let me go ahead and just run this. I already compiled it just to make sure I didn't have any typos. Yeah, so the first color is red. Tells us that right there. So this technique here, this creation method is known as list initialization because I'm just giving the vector directly a list of values. I just want to point out too, I can copy and paste this, and there's another version of this. I can just say colors2, and I don't need to put the equals in. So this will also work. Let me just compile this and show you that it does not give a compilation error, but I don't think I'll do more than that. There we go. No compile error. Perfect. So this also works. I got a little shortcut here. I think this might be C++ 11 and above feature. So if you're not using C++ 11 and above, that might not work. All right, let me put some headers in so to break this up into some categories. One sec while I organize my work. All right, there we go. So I've got a section for initialization, section about accessing. One other thing I want to point out too, really common mistake, let me go ahead and create colors3 here. Colors3 is to use the wrong kind of bracket. Whoops, wrong one. Replace 3, replace parenthesis, and replace the parenthesis. This does not work. Change my comment. Does not work. This is a really common mistake. Here, let me just go ahead and run this compile and show you guys the ginormous error that we expect, or that we get. Let me scroll up here. The very first error message is the most important one. It's going to tell us there's no matching function call. And oh, my first thought is, what? What does that mean? Let me go back to that line. It's looking for a function call. So it's basically trying to use the constructor for colors3, for a vector of strings. And there isn't a constructor available that takes 3 strings as a parameter. And so that's why the function call is available. It's trying to call the constructor, is that function that we're trying to call, to create this data structure, the vector. And there are versions available. I'll talk about some of those in a moment that do take parameters, but this is not one of them. So this is a common mistake that I make when I screw up and put in the wrong kind of braces. And that error message was horrendous. It took up like 2 full screens of stuff just to like tell me that I've used the wrong kind of braces. All right, next up, we can also change the data with this element access. So if I go ahead and say colors, and then we'll go ahead, 0 is equal to orange, that'll go ahead and change the first color. So the first color is now that. Okay, let's go ahead and compile and run this. Whoops, I made a mistake here. Hold on. No, I didn't comment that other line out, did I? This one fails. Right. Compile. And run. Okay, yeah, the first color is red. I changed it. The first color is now orange, looking right there on that part of the screen. All right, some other really common things that we're going to want to do. So this first section is just going to be just the basics. Is get the size of a vector. Colors.size. Okay, yeah, so there's just a method available for the data structure for the vector that's got size and tells me exactly how many elements there are. So run that. 3 colors in the vector. Let's go ahead and print all of them out. So one way to do that, I could obviously just write a for loop. Let me go ahead and do that real quick. So this version is just going to use a standard for loop for I equals 0, I is less than colors.size, I++. We're going to be accessing colors right there. Let me actually try to make this spaced out a little better so it looks good. Yeah, Yep, prints it out, adds a space after it, and then we'll put a new line after we're all done. Let's just see what typos I made. Yep, too many of those. Run this, and here we go, orange, green, and blue. All right, there's another option for writing this loop. This one took me 3 lines to write. I could also use, for string s in colors, cout, we'll just print out that string, followed by a space. There's the end of that line. So that's going to be the entire contents of the loop. And then when I'm done running that 1-line loop, I'm just going to go ahead and print on a new line right there. So in 1 line, I'm about to do the same thing I just did in 3. So write that. We'll figure out what typos I made. Ooh, no typos, sweet. And we'll run that, and exactly the same thing. Orange, green, blue. So this version is going to go ahead and grab each of the items of the data one at a time from colors. It's an iterator version that, to be honest, C++ is just going to take care of all of that, coming up with an iterator, getting the pointers to the object, dereferencing them, doing all of that for us, so I didn't have to worry about any of that weird stuff right there. All right, next up, let's go ahead and add more data to this vector. So to do that, the function that I want to call, or the method that I want to call from the vector library, is known as pushback. You can think about this as kind of like as though I were thinking about a stack. So pushback, I can give it a new element to put in. Let's put in black. And then I can do, here, let's just copy and paste some of these lines. I can check the size again. And then let's go ahead and print out everything using that version, because it's 1 line to copy and paste. All right, right. Compile, no typos, and run. Okay, here we go. So here were the 2 versions of printing, orange, green, blue. I added black, so now there are 4 colors, so the size increased. Like I said, vectors are dynamically sized. If I add more stuff to them, it's going to go ahead internally and take care of all of the arrangements to make sure there's enough size. And then I've got 4 colors, orange, green, blue, black. It's really bothering me that the orange is capitalized and the others aren't. I'm going to fix that right now. All right, got that fixed. And I went ahead and put in a whole bunch of extra comments to sort of divide this up into some sections. So we've got a section about iterating through. I've got 2 different kinds of loops. Here's a section about adding data. There's size. And I added a comment here about the templating. All right, so the next thing I want to do, go ahead and add in like a page break here. So we'll do, how about percents this time? So the next sort of big topic is, let's talk about more ways to initialize vectors. So this was the list initialization. This is great if I know what data I want to put in. And it's great for like classroom demos, but I think I've rarely used that. Instead, what I'll most frequently do is actually initialize an empty vector and then fill it in. So to do that, let's see. And let's switch up to numbers this time. So we'll create a vector of integers. Let's call it numbers. And that's all there is to it. So just like I would do int x, that doesn't take any parentheses. There's nothing special about it. Just like that. That's all there is to it. Really common mistake, and I catch myself doing this all the time, is I feel like I need to call like a function, a constructor, to construct an empty vector. So I find myself writing this. Numbers 2 with, hey, I want it to be empty. I'll put in empty parentheses here. This is completely wrong. This is going to fail. And I'll show you in a second what the error message says. But this is exactly what, N-U-M-B, wow, horrible spelling today. This is exactly how you would declare a function. So right here I've got main. If I were putting in some function prototypes, up here I would have a return type, int, or in this case vector of int. That's my return type, my function name, numbers 2, and then it doesn't take any parameters there. This is me telling C++ that I'm going to be defining a function later, like down below main, where it's called numbers2. It doesn't take any parameters, returns a vector of integers. That's what this line does. And C++ will confuse that line, let me get rid of it, with this one. And so this is not the correct way to declare an empty vector. I don't believe it fails here. It doesn't actually fail until we try and use numbers2. Let me go ahead and compile this part. See, it compiled just fine. I can run this. It ran just fine. There was no error there. But now check this out. If we do numbers, just the first one, the one that should work, we'll put some data in it. Push back. Let's put in 0. And then push back. We'll give it a 2. Oh, wait. And then in numbers2, let's put in -2. I'm failing at typing today. Insert 2. There we go. Okay. -99. Let's see here. All right, and then we need to print this out. So let me, all right, so I've got some code that's going to write these things out. Cout numbers, and then it's just going to go for n in numbers. That's going to grab the first number, and then cout n, add a space. Then it's going to send the second number, add a space. This is the only statement in the loop, and then this is going to put an end line. All right, I know it's bad practice to put like everything on one line, but I kind of feel like it goes well here because it's all just printing something out. And as far as like lecture go, I want as much stuff to fit on the screen as possible. So I'm making my style really condensed. Apologize if that's confusing to anybody. As you're going through the template, feel free to take everywhere you see a semicolon and go ahead and add an enter and spread it out. So if it fits on your screen. All right, let me go write this. Then I'm going to compile this. And this is going to fail. And it's not going to fail until we get to, where's the first error message? Yep. Error request from member pushback in numbers2. It thinks numbers2 is a function. It says it's non-class, so it thinks it's a function. It's not a class. It's here's the return type. Returns a vector. Whoops, that much. Starting right there. That much is the return type, and it's a function. So that does not work. So let me see here. Go back to the code. This is one of those like gotcha situations where you can make a mistake like up here and not notice it until you get to down here. So heads up, and it gives you the error message right here, and there's nothing technically wrong with this line. The only thing wrong was up here I had 2 extra parentheses. If I take those out, this will work just fine now. Or at least it'll tell me where my next typo is. Yeah, it works just fine. Let me go ahead and print that out by actually running it. There we go. So numbers 0 and 2, numbers 2, -299. It's working great now. I'm going to go ahead and leave it in with the pieces that fail so that you guys are going through. You can like uncomment it and watch that happen yourself. All right, next up, the next way to construct a vector. Let's see here. C++ does have a parameterized, I'm not sure I spelled that right, vector construction. And to do that, I will be giving it parameters. And so I'm going to have, let's make another vector of int, vector int, let's see, I'm up to numbers, we'll go with 3. I'm going to give it some parameters here. And the parameters I'm going to give it, we'll give it 10 and -2. And then we'll go ahead and we'll just print this out. Let's see here. Copy and paste this line of code right here, and we can see what this does as a little experiment. And then I'll go ahead and explain. So in this case, we've got numbers 3 for n in numbers 3. So the first time through, it'll go through the list, grab the first number from the list, print it out. So here we go, compile, done, and running the code. So what it's done is it's created 10, a vector of size 10, and it's assigned every single value -2. All right, so we've created 10 positions. They're all -2. So let me just put in some comments here about exactly what's going on so I can like have something to point to with my mouse pointer. Okay, so when I'm calling this constructor to create a vector, I do need to give it a type. I need to have a name. But then the two parameters here are size, and in this case I was using 10, and the default value, which is going to be automatically set to 0 if I don't give it. So it's actually the variable default value has a default value. Let me just do one more example. I'll grab 2 lines, we'll paste those, we'll have numbers 4, and we'll just create a vector of, let's do size 4. So that should give me 4 zeros. Next up, we need to replace that 3 with a 4 and that 3 with a 4. So this is using the default version. So when I run this, I should get 4 zeros in my vector. If I want to, I can go ahead and add in another number. We'll just do numbers 4 push back, and we'll add an 8 to the end of that. And now we've got 4 zeros and the 8. The 8's going to go on the back of it. These are 4 real data values. It's not going to replace any of them. So I'm not going to like fill in the first one. It just gets added to the end. And now I have 5 values. All right, another little gotcha. Here, let me go ahead and grab these 2 lines again. Paste them again. Let's see, and then we'll change this from numbers 3 to 5. I'm going to replace this with the curly brackets. Go back to a slightly different version. Place that one with curly brackets, and then I want to print out numbers 5. So R5 and R5. Okay, I don't want to go by this too fast, so take a look at what this is doing. Make a guess as to what you think this is going to print out. Then I would encourage you to actually try it yourself, and I'm going to go ahead and demo it right now. Compile that and run this code. It's actually printing out the numbers 10 and -2. It didn't go ahead and create 10 -2s like we had up here. And the reason for this is that list initialization version, like we talked about at the very beginning where I was doing that thing. Basically, I'm creating a list. I'm giving it to colors here. I don't need the equals. I can just call it like that. So it kind of looks like a function. Like I'm calling a function, but it's not. This is the list initialization version. So this is very different from this. This has size 10, this has size 2. Here they're all -2. This one is 10 and -2. So I'm just going to put a comment right here. Very different from the version with parentheses. All right, so far we've talked about constructing from a list, constructing an empty vector, constructing the parameterized version where I'm giving it how many I want and my default value. Next up, we've got copy constructor. So if I have a vector of int, I'm going to call this v1, and I'm just going to give it some values. There we go. There's some values. I can say that vector int v2, just like that, is going to get the contents of v1, just like that. All right, let me go ahead and print both of those out. Copy and paste some code. Give me a sec. All right, so I added my print statements. It's just going to go print out v1 for number in v1, print it out for number in v2, print it out. Let's go ahead and me write this, compile, and run it. Yeah, right down here at the bottom, I can see that I've got v1 with the numbers 1 through 9. v2 has the numbers 1 through 9. All right, next thing I want to demonstrate is that it's making a copy of the elements. It's not actually just creating a pointer that points to the same object like you get with Python or something. So here, let me just change one of them. So we'll take v2, we'll get element 4, which is the 0, 1, 2, 3, 4. It's actually the number 5. We'll just replace that with a big number so it'll jump out at us. And then I'm going to copy and paste those 2 lines again. I'll print it out. Right. Compile and run. And now I can see that here's v1. It is not changed when I changed an element of v2. They are independent. And I think every year when I've taught this live, someone has asked, is this shallow copy or deep copy? And it depends, because it's going to be calling the copy constructor for all of the elements one at a time for whatever type this is. In this case, it's an integer, so it's just going to make a copy. and there's not like any depth to it. But for like more complicated data structures, it calls the copy constructor for whatever that is, and that could do either. So you got to be a little careful. And we'll talk about how to do that when we talk about operator overloading in about 3 lectures. All right, there's also another version that I can write to do basically the same thing. I can write a vector of int v3 equals, in this case, v1. This is going to actually do the very same thing. Here, let me just copy and paste this line. I'll do replace with 3, replace with 3, and we'll put another copy of that here. And then we'll also try and change v3. Let's do element 5 this time is equal to 888. And let's change v1 too, just to like element 2 is equal to 777. Right? Just to be like very thorough. All right, so in this case, I've got 3 copies. Here's my originals. And then I've changed element 1, or vector 1, and it did not change any of these others. Vector 2, I changed one of the elements, it didn't change the others. And vector 3, I changed one, it didn't change any of the others. These 2 lines do the exact same thing when compiled. All right, so I've got this section labeled copy constructor. Something, very similar we can do is assignment. In this case, I'm going to create an empty vector of int. We'll call this one v4 because I'm just going to continue along. All right, right now that's an empty vector. Then I'm going to do v4 equals, and we'll go ahead and do v1. This is the assignment operator right here. This one here is actually gets turned into this one by the compiler as it's being created. So this is the copy constructor version. And the only difference is that I'm declaring the variable here on the same line as this one. I'm declaring it first, and then I'm going to be doing some assignment. So let's go ahead and see what happens when we do this. I've got that. Let me just print out v4. Replace with 4 and replace with 4. Right. Compile and run it. So v4 here is now an exact copy of that modified version of v1. All right, let me go ahead. Let me change both of those and just show you that we're actually making copies. So this assignment, element by element, copies things over. Let me just grab that line, paste that one. It needs to be v4 element. Let's do 7. Replace with a 7. There we go, and do 555. There we go. Whoops! Holy cow! Finally got that fixed. Changing one of the elements in v4 to 555. Another element in v1 to 222, and then I'm just going to print them both out again using that same code. We should see that they are different. There we go, run this. Yep, so I'm looking at these bottom 2 lines here. Those are the last ones I've changed. So I changed one of the elements in v1, did not affect v4. I changed one of the elements in v4, did not affect v1. So they're actually all independent copies. That's the default version for things. We're not actually creating pointers to new things. If I wanted that, I have to specifically say I want a pointer to this thing. All right, next up, I want to talk about the range iterator a little bit. This is the for loop that goes through all of the values in something. And references. Here, let me write some code and I can come back and point to it with the mouse. Okay, so I've went ahead and wrote some code. I want to point out too that I've added a system call here. This is the system just goes to the command line and types in whatever is here and executes that. So in this case, I'm just going to clear the screen using that. This is a system dependent. This is the version that works on Linux. Let's see here. So for the range iterators and references, I'm creating a new vector, v, it's got 1, 2, 3, 4 in it, and I'm going to try and double it. So the first thing I do is I'm just going to print out the original so we can see what it looks like. Then I'm going to use this range iterator style loop. I'm going to use auto here because I'm starting to feel lazy. and int would have actually been shorter, but auto is just sort of natural for me, so I just typed auto. That's going to say that it's going to go look up what type of thing v is. It knows that it's a vector of integers, and so it's going to grab that piece right there and replace auto. This is a C++ 11 feature where I don't need to remember types anymore. It'll help me out. So you'll need C++ 11 features turned on for that. So it's going to grab n. It's going to say n times equals 2. It's going to double it. Normally that would be like n equals n times 2. So I'm assigning to n right here. N is now actually bigger. Here, let's do this a little differently. See out. N space. We'll call that good. And then after the loop, we'll do cout. Whoops, just that much. All right, and then I'm going to need some parentheses because this is all in the same loop. And a space. There we go. I like that. So then I'm going to print out the loop, the vector v, and see has it really doubled? Have I really affected anything at all? So let me write this, compile right there, and then we'll run this. So it clears the screen. Here's my original vector, 1, 2, 3, 4. I doubled n. I'm printing it out to show you that they actually doubled. N is now 2, 4, 6, 8 as we go through, but it never went back and updated the original values in the vector. Those are still 1, 2, 3, 4. It's very easy to make that change though. I'm just going to copy and paste this code. One sec. So I grab 6 lines. I'm going to paste those 6 lines right here. So now I should have 2 copies. Here's my for auto n in v, for auto n in v. I'm going to make one little change, and that's to say this is now a reference. Right there, one little change. So int reference to the values in v. And now when I do this, this isn't actually referring to a brand new copy like we were making up here. Now we're actually doubling things. And so when I print out v again in this bottom line right there, that one, we should see that it's actually changed v. All right, so let me compile this. I'm really kind of excited about that system call clear. I like the way it leaves the screen like clean and fresh every single time I run this. Okay, yep, here we go. Check this out, it worked. Here's the original. Here's the version that did not have the ampersand. Here's the version with the ampersand. It's a tiny, subtle change. If you leave it out, you'll get behavior you don't expect. And those are the worst kinds of bugs where it doesn't just crash and tell you what's wrong. The ones that just give you the wrong answer, those are the worst. All right, so next up, I was trying to come up, I did some formatting, so I've got some more line breaks in there. I moved my clear down. The next section I want to talk about more ways to access elements, some functions that are kind of nice to have. I don't know if advanced is the right word for this. It's just more, I guess. The first one we talked about already was just using the square brackets to access pieces of the vector. This works great. We've also got a couple other versions where we can do something like grab the first element, that's the front of the vector. So colors dot front, it's a function like that. We can there's also back. So let me quick replace that with back, and we'll do back here. And then there's another version of something very similar to with the bracket notation, the at function. Dot at. We'll grab the piece at 0. Dot at 0. So this is essentially the same as the bracket, but the at will actually check to make sure that things are in bounds. So it's safer, but a little bit slower because it's got to verify that the number is positive or 0 and less than the size. If you know you're in bounds, you could just go ahead and get away with this. If you want to crash your code if anything goes wrong, a little safer, go ahead with this one. Let me demo this. Right. Let me find all my typos. Ooh, no typos. And we'll run this. Okay, so here's my list of colors: orange, green, blue, black. Colors at element 1, that's the first way we talked about accessing the data. Front is just going to get the very first color. Back is going to get the very last color. And the at will grab whatever number it is, but it'll crash the code if it's out of bounds. So let me go ahead and put in colors at, how about insert mode, minus 205 or 2, yeah, that one. Minus 2040. All right. So that should not even compile. I mean run. Yep. So here it is. It's thrown an exception out of range. We can handle that using try and accept if we wish. In this case, I'm just going to put that right back. So undo. There we go. And we'll keep that. I'll put a note here real quick. There we go. No bounds checking, and throws an exceptions if it's out of bounds. Something else that I think a lot of people find really weird is that colors.front, that front function actually returns a reference. So I can use that on the left-hand side of an assignment statement. So when C++ evaluates this, it's going to say, okay, this just points to some memory in that vector, and I'm going to be changing it. Let's see, what's another great color? We'll go with cyan this time. So I can use something like colors front to change the very first one. I'm going to grab my printed out line. That's not right. Oh, hold on, I'm typing all over the place. Okay, there we go, got all the typos fixed. I'm just going to print out the entire list of colors after I use front to change one of them. There we go. Now we have cyan as the very first color, upgraded with that colors.front. Yeah, a lot of people who haven't seen this before feel it looks really weird. This is just that return by reference mechanism that we saw in the previous lecture. 2 lectures ago. It was the really long one. All right, so just in this section, the like everything we can do without needing iterators section, I got 2 more things. First, creating a vector of vectors. This is going to be something like a matrix where I've got a bunch of rows and each row is a vector itself. Okay, it's just like this. Vector of int. This is going to be my row. So I do something like that. But if I want a full matrix, I need a vector of rows to create a matrix. Now the gotcha here is that I can't put both of the greater than angle brackets next to each other. I absolutely must have a space, because this bracket is the stream stream extraction operator. This is the one I use with cin. And C++ says this has high priority. It looks at this first and says, okay, we're doing a stream insertion into the variable matrix from, wait a second, this much is not a stream and it's going to crash. To make this work, all I need to do is make sure they're not next to each other and insert a space. And we're going to find that we have lots of opportunities for nested containers inside of other containers. And in every single case, we have a container inside another container. We're going to end up with these brackets. The temptation is to just squish them together. I am a huge fan of really condensed code. So this was a problem for me for a long time. I'm just going to leave this right here. We'll come back to this when we start talking about maps and sets and things like that. All right. Last thing. Oh, I went ahead and added a comment here. Just another gotcha, add a space. C++ might think you want this stream extraction operator, something that's going to take something from the console and put it in a variable if you don't have that extra space right there. Okay, last thing, relational operators. Key here is they operate element-wise. So it's going to take the first, the piece at element 0 and the piece at element 0 and the other thing we're comparing it to. If I compare it to element, let me get a demonstration. Okay, so here's what I really mean. I've created 4 vectors here. I've got some numbers. So n1 has 1, 2, 3. n2 also has 1, 2, 3. Those are the same. So my first test is going to be to ask, are they equal to each other? This works element-wise, so it's going to compare the 1 to the 1, the 2 to the 2, and the 3 to the 3, and say true. The next thing I'm doing is declaring another vector with 2, 3, and 4. And then I'm going to ask, is that equal to 1? So it's going to compare the 1 to the 2, and get false, and then it's just going to be done. It's going to compare 2 to 3, 3 to 4. It already knows it's false. It's going to skip the rest of those. And then, so this should return false. So we'll get a true, a false. The next thing we're going to do is the less than. This is going to take n1 and compare it to n2. So is 1 less than 2? True. Is 2 less than 3? True. Is 3 less than 4? True. This one will return true. All right, and again, it's element-wise. They all have to be true, all comparisons before it does anything. So if I do something like 052 and say, is n1 less than that? So 1 less than 0. Nope, it's not. It's done. It's going to return false right there. All right, I've got my bool alpha, so it's going to actually print out true and false instead of the 0 and 1. Let me just go ahead and run this. And we can see we get true, false, exactly like we expected. All right, I'm going to let you guys experiment with the rest of those. All the relational operators work the same. One gotcha that I'm going to go ahead and do a little experiment here. I don't remember exactly how it works, but what if I have a vector that's longer? I'm just going to add an extra piece and see what happens. So I need to compile this and then run it. False. Let's add another one here and try it again. 1, 2, 3, 4. Compile and run it. Okay, so now n1 and n2, they had been returning true. It had 1, 2, 3 and 1, 2, 3, but now it's 1, 2, 3 and 1, 2, 3, 4. So they no longer have the same length, so they're not equal. That makes sense. And this was asking n1 and n3. I changed n2. That's the only place I used n2 here. Okay. All right, it didn't crash. It didn't give me any errors. It just returned false. I'm going to let you guys do more experimenting on that if you so desire, and I'm going to move on to iterators. All right, I just looked at the timing. This lecture is going to be longer than I thought it would be, so I'm going to move most of iterators to the next lecture. Right now we are just doing the minimum basics to continue on and talk about the rest of the vector functions. So an iterator is a pointer. It's almost like a pointer. And for vectors, there's really very little difference. So the way vectors are like libraries that help us work with primitive arrays, iterators is a library that helps us work with pointers, basically. So there's a lot of similarities there in the same way. To declare one, every single container, so in this case a vector of integers, has its own iterator. And it's going to have this type when I create it. So here I'm creating a variable called it. This is the type of it. And to be honest, we will almost always be creating an iterator using a vector. So in this case, I'm just going to go ahead and use vector n1 right here. I might change that in a second. n1.begin. So we had front and back. Those actually gave me the data from the first and last pieces of the vector. Begin and end give me pointers to the first element, and then end will give me a pointer to the element after the last one. So I can use less than on that in loops and see that I'm not yet done iterating through the loop. All right, let me demonstrate that real quick. Let me change this a little bit so I have a good demonstration. Okay, here we go. My example is going to be sorting. So I went ahead and created a new vector with some just small numbers that are all mixed up. They're not sorted yet. Here we go. This is how we create an iterator that points to the very beginning of that other element. So this is a pointer to that element 4. Like I said, this is kind of a lot to remember to type. The vect int iterator, every single container has its own. But auto will go ahead and say, oh, you're calling this function end? I need to know what type that is. And it will go figure out what type it should be. And then I don't have to worry about remembering to type all of this. I'm going to try and do it for the class just so I can point out that, hey, I'm really creating an iterator. That's what begin is getting me. But this is so much easier, and I'm probably going to be lazy. All right, so the next thing, to use this, let me just bring this back up. As an example of how this could be used, I'm creating I already did it. So I just told you I was going to put iterator so you remember, but I forgot. I'm already back in autopilot mode. Here, so I'm just doing a for loop. I'm going to create an iterator, or basically a pointer, that points to the very first element of this list. So it points to 4. Star it actually will get me 4, which is what I'm going to be doing right here in a moment. I'm just going to print them all out. After that, I'm going to say while it's less than a pointer to something past the last element. So when it points to this last element, this will still be true. The moment we increment it, and again, pointer is just when we increment it, it's going to point to the next thing. then this will no longer be true and it'll end the loop. So here we go. This is how this works. Let me go ahead and just run this piece of it. So we'll write, compile, and run it, and it's going to go through the list and just print out all of those numbers. Okay, there's actually a whole lot of functions that accept pointers or iterators to things. Like there's a constructor that takes an iterator. Let me demo that real quick. So I have vector x2, it's of type int, and I can just give that, it's a parameterized function. I give it the pointer, or an iterator, x.begin, and then I need the beginning and ending. So let's go with x.begin, and then pointers, so I can use regular pointer arithmetic, begin plus 4. That will go ahead and copy all of these elements into x2. Let me compile that. No typos. Oh, it's not going to do anything. Let me add a line that prints that out. Okay, here we go. I've gone ahead and added a line that's just going to print out x2. It should copy from begin, which is the first element here, 4, and then we'll grab 4 things, so 4, 3, 6, 2. And as soon as it gets to this one, x plus 4, that's this one's inclusive, that one's exclusive. It should stop, so we'll get 4, 3, 6, 2, the very first 4 elements of that. Yet another way to construct a vector. All right, next up, sorting. So I've got some code written here. This is just going to print out x. This was that vector right up here with the numbers all mixed up. It's going to call sort. This is a function built into the algorithms library. There's a lot of great functions, and almost all of them are based on giving it a pointer to something and a pointer to one past the end. So an inclusive pointer and an exclusive pointer. And it's going to do something on that range of data. So in this case, I'm going to be sorting from the beginning of my vector to the end of my vector. And then this line just prints it back out again. Okay, let me go ahead and compile this. Right. Compile. Whoops, what was that? Where's my compile? Sort not to, oh, right. It's in a library called algorithms with all these great functions. Let's go back up to the top and include that great library. Algorithms. Oh, I wonder if it's plural. Let's find out. Compile. Let me double check how to spell that. Okay, got it. It's just algorithm. It's not algorithms. So now, all right. It compiled the last time I tested it. So if I just do a.out, here's my original list of unsorted numbers, and here is the sorted numbers. Internally, I believe the C++, last time I looked, which was several years ago, the C++ sort library used quicksort. I could be dead wrong on that one, and I didn't go back and double check for you guys. All right, maybe just a couple more examples. I really have no idea how long this takes because I pause, I write code. I've been working on it for almost 6 hours now. And I don't know how much footage I've collected. I have no idea. But anyway, so just a couple examples here. I just want to demonstrate at least a couple more where I'm using these iterators. In this case, insert. So I'm going to be taking the numbers from x2 and putting them into the vector x, just inserting them in the middle. And the command for this is just the name of the vector they're getting inserted into, insert. But this takes 3 things. It takes the starting location, and this will like shove everything from that position on down to make room. So if I give this x begin, that's going to be starting at element 0. It's going to shove everything down. In this case, I'm going to leave the first 2 elements, and I'm going to put in x2 from the beginning of that vector to the end of that vector. So it should grab all 4 numbers. We'll print that out. All right, I didn't actually test this. Let's see if it compiles. Okay, good. Let's see if it works. Okay, so here we go. Here's my x. When we left off, it had been sorted. I'm going to take and leave the first 2 alone. This is the begin plus 2 position right there. It's going to shove that over, and I'm going to stick the 4, 3, 6, 2 in beginning right there. So I keep the 2, I keep the 3, then I put 4, 3, 6, 2 in the middle, and then the rest of this, 3, 4, 5, 6, 7, gets stuck on the end. So let's take one more look at that. Insert takes 3 things. Where in the vector I want to start inserting things, and then the beginning and ending positions of what I want to insert. And again, so many of the things in the vector or containers and so many things in algorithms just take a starting position and an ending position. They're inclusive, exclusive, and operate on those things. So this is a really powerful technique, something to get good at. Let me actually pull up the web page and maybe finish up by talking about how to get information about the rest of the techniques out there rather than demonstrating all of them myself. All right, so here I am. I'm looking at the C++.com website, navigated to reference and then vector. Here's some great information summarizing how vectors work. Over here, I've got the list of all the containers. So if you're ever uncertain exactly which one's which, do I want the unordered versus the ordered? Do I want the multi version, multi-map, multi-set, whatever? They're all linked right there. This is a great place to just have open for the next many homework assignments. All right, tells you a little bit more about how they work. I'm going to skip down past member types to member functions and just take a look at some of these things. So they're broken down. I've got the constructors. Here I've got the iterator versions. So far I've only talked about begin and end. We've got a bunch of stuff related to capacity. So here all I've done is like read the size, but I can also say things like go ahead and resize it. If I want to shrink it down and eliminate some stuff from the end, I can say what is the maximum size. I can say reserve a bunch of extra space. All of these are, as a programmer, I know that I want things to be optimized a certain way. If I know I'm going to be adding a ton of stuff to my vector, I can tell it how big it's going to be at the end. And then C++ won't go through, add something, and then move it to a different location in memory to make space for the next thing. It can just find the right block of memory for the whole thing right away. Here's all of the element access that I've talked about. The modifiers, the only one I really did here was push back and insert. Demo those, but here's why I want to go to this page to show you guys how to look up the rest of the things that can be done here. All right, let me just take a look at the constructor page. So let me open this in a new tab. We'll pull this up and talk about how to read this because it can be confusing. Start right here with the, so these four things correspond to these four things up here. So like this first one, construct an empty container, default constructor, empty container with no elements. That's what we did with just vector int, give it the name, and no parentheses. All right. Then some of these other things like the fill constructor. This is the one where you have to give it two pieces of data, the number and the default value. And I guess this is actually really confusing to try and read, is it not? So size type, that's going to be the size. This constant value is the value it's going to be inserting into everything. This is just telling me that it's going to, if it's an object, it's going to call the default constructor given the value. Let's see what else we got here. The range constructor. This is going to be the version that's getting the iterators. So I gave, when I created that x2 variable a moment ago, I gave it an iterator to the very first thing I wanted to create and an iterator to the very last thing, exclusive version. And it copied all those into this new one. And then this last one is just the copy constructor. I did this one also in the middle of the lecture. It's just going to copy all of the elements in X in order into the new vector. Okay, so this can be kind of hard to read, but they've got a description of how it works here. And typically they have some examples down at the bottom. And then some like analysis. So let's go back. Let's take a look at some of these other things that we can do. How about pop back? So if I take a look at pop back, this is just going to delete the last element, and this particular version doesn't return anything. So if I want that element, I need to go ahead and grab it using back before I pop it back. So good to know. I was about to tell you that it returns the last element. Nope, it just erases it. Return value none. Delete the last element. This destroys it. Okay, good to know, good to know. I was about to get that wrong. Yeah, I found something that's going to be a great example. I should probably really demo this, but I'm running out of time. So erase is actually going to require an iterator to say which one I want to be removed. So I can't just go and say erase element 4. It's going to have to be erase, and then I'm going to need to do x.begin plus 4 to get to that fourth position to erase. This will also erase multiple elements. It just needed to give it an iterator the first and the last. and it'll go ahead and create a new array, a new vector without those elements. And again, that's inclusive and exclusive. And there's some demonstration of that right here. I'm going to let you guys do the demo. I'm out of time. I'm not going to have a chance to do this. Clear is another one that I want to talk about. This is just going to remove all the elements for a vector. They're destroyed. Container size is then 0. Basically, it's swapping out the vector for an imaginary brand new vector without anything in it. So there's a demonstration of how it works right here. I'll let you guys take a look at that one yourself. And then finally, empty just returns true or false whether the size is 0. So this is a great way to test if a vector is empty. You can also do x.size equals 0, and that'll give you the exact same thing. All right, I'm out of time. This has got to do it for me today. I'm going to go ahead and get this edited, assembled, rendered, and thrown up on YouTube, and I'll send you guys an email. Have a great day.